Hello, everyone. I hope you guys are having an awesome day so far. Um, as you guys can clearly see, I am not there. Fascinating, right? Not there, but I am here. All right. Anyway, so I am going to present a little information in this video so that you guys can complete the worksheet that your substitute will hand out to you. Um, and then when I come back, we will review. We'll go over the topic a little bit more. Okay. So in this next chapter, we're going to be talking about energy. We're going to be talking about light and how it travels and everything that the speed of light. That went by so fast. You know what I'm saying? Like, didn't even see it. All right. So to start off, let me pull up the PowerPoint. Okay, here we go. So chapter 4. All right. So we're going to be talking about light. So light is an electromagnetic spectrum or radiation that all travel the same speed. Light is always going to be 3 times 10 to the 8th power meters per second. Okay, that will always, always, always be true. You will probably memorize that number by the end of this chapter. 3 times 10 to the 8th meters per second. Okay, that is what the speed of light is. Okay, now on the this is the electromagnetic spectrum. So you got radio waves, you got microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. Okay. Next week we're going to be doing a research project about all these different types of electromagnetic spectrum waves. Okay. But for now, what I want you to see is the energy. So the energy increases going left to right, which means the frequency increases. But if you go look at this arrow, the increasing wavelength goes from right to left. Okay, so that's the electromagnetic spectrum. Okay, as a review, we're going to talk about some waves. So a wavelength is from the crest to the crest or the trough to the trough. Okay, those are two easy ways to analyze what the wavelength is. The frequency. So what the frequency is, the number of waves that pass through a given point. Let me get these off the screen. Pass through at given point through a specific amount of time. All right, so it might be 1 wave per second. So the unit we're actually used for frequency is hertz. Okay, it is hertz. All right, so we're going to relate these two. Okay, relating wavelength and frequency. If you decrease the wavelength, you increase the frequency. Whoa, that was kind of confusing. Mr. Bowers, you're just talking Spanish right now. But this is the equation right here, okay? And that's what we're going to be using for a decent amount of these problems, okay? C equals lambda. Lambda is the wavelength times frequency, okay? So let's try a practice problem. Oh, don't want you to see all the answer. Here's our first problem. It says light as a wavelength appears, a light with a wavelength of 650 times 10 to the negative 9th meters appears red to us. Calculate its frequency. Okay, so what you're going to do is here's a piece of paper. You're going to calculate the frequency. Okay, so my wavelength is C times the wavelength times frequency. Okay, there we go. Where C is always 3 times 10 to the 8th power. And in the problem told us that the wavelength was 650 times 10 to the negative 9th meters. Okay, and that's times it by our frequency. So what you're going to have to do is you're going to have to divide 650 times 10 to the negative 9th on both sides. So that cancels with that, and our frequency is equal to 4.62 times 10 to the 14th, and our unit is hertz. Okay, All right, if you're listening to WHKO in Dayton, Ohio, all right, you're listening to 99.1 FM, which has that hertz. What is the wavelength? Okay, I want you to pause the video. I want you to try to solve it out. I want you to try to solve this one. All right. All right. So hopefully you got it. Let's look at our answer. You wrote out your equation. Oh, I didn't go over the answer. Well, I'll do it here over on this. So you got 99. What was our number? I'm going to go back here real quick to write it down. 99, 1 with 5 zeros. 1, 2, 3, 4, 5. Okay. And that's equal to the speed of light times it by the wavelength. Okay. So that's what it looks like set up. Okay. So you're going to divide by 99, 1 with 5 zeros. 99, 1 with 1, 2, 3, 4, 5. Okay. That cancels that. Now, your answer, I'm going to get a calculator out. If you need to borrow a calculator, you will find it to your left. All right. It is on the table. Okay. 3 times 10 to the 8th divided by 99.1. I got 3.03 meters when I plugged it in. I got 3.03 meters. Okay. Hopefully we feel comfortable with that. Okay. So as a review, what are electrons? We know what electrons are. We know that Rutherford's model of the atom didn't tell us much about them because he discovered the nucleus. Okay. However, new experiments in the 1900s found a connection between light and electrons. Okay. Which the photoelectric effect it comes into play. All right. So on Monday, I'm going to do an experiment that represents the photoelectric effect. And it's pretty cool. I actually won it at a conference one time. All right. So what it is that light hits a substance. And from that substance, it bounces off. Okay, the light particles bounce off and reflect a different light. Okay, so I'm going to show you an example of that Monday. Okay, so to explain this photoelectric effect, Max Planck was the guy who tried to do it. All right, so he proposed that rather than emitting energy like a wave, objects emitted energy in packets. Okay, and these packets are the quantum. So quantum is the minimum quantity of energy that can be lost or gained by an atom. So this formula is E equals H times V. So this is the second formula we've learned. E stands for energy. H is always going to be a constant. H is always going to be 6.626 times 10 to the negative 34th. That's a very, very small number. And of course, he's going to name a constant after himself. And then V is frequency. Okay, so let's try an example problem. What is the energy of a photon if it has a frequency of 4.62 times 10 to the 14th hertz? Okay, well, if we write this out, energy is equal to H times V. So energy is equal to 6.626 times 10 to the negative 34th times 4.62 times 10 to the 14th. And that's how you would set it up. Okay? There you go. And your answer should be 3.06 times 10 to the negative 19th. Okay? So scientists thought that light acted like a wave until the 1900s, and we developed that equation. Light is a part of the electromagnetic spectrum, and we discovered a photoelectric effect that created Planck's constant. Okay, and here's Planck's constant. Okay, using these two formula, you should be able to find energy, wavelength, and frequency for any photon if you are given one of the three. That's pretty cool. So we're going to try to combine these two. Try to combine. What is the energy of photon of light? It has 400 nanometers. Nano is 10 times 10 to the negative ninth. Uh-oh, we got a tricky one. So I'm given meters. I'm given wavelength, lambda, right here. I'm supposed to solve for energy, which is over here. So what you got to do first is solve for frequency. So frequency gives you V. And from that V, you can plug V into your equation over here. All right? And that's what it looks like. All right? And that's how you solve for energy. All right? I hope this kind of made some sense. All right? It's kind of throwing a lot at you, a lot of two different equations, two different constants. The speed of light never changes. It is always 3 times 10 to the 8th. All right? Planck's constant is always 6.022 times 10 to the negative 34th. All right? 6.626, my bad. So try completing this packet. Get as far as you can. If you guys have questions, I will answer those on Monday, and I will go over the photoelectric effect. Okay. All right, guys, I hope you have an awesome weekend. Hang in there. I will see you on Monday. Have a good weekend.